everyone, today I will introduce the free body diagram of FBD. When studying physics, we need to turn real world scenarios into maths equation, and FBD is the perfect tool for this. First, it isolates a single object and represents it as a central point. Then we draw all the force acting on it. These include gravity, normal force, applied force, and friction along a coordinate axis. By removing background distractions, this diagram helps us break force into horizontal and vertical components using trigonometry. Once that is done, we can directly apply Newton's second law, F equals to ma. This method works for many classical mechanics problems. The process is exactly the same whether an object is resting on a flat table, sliding down a tight incline, or accelerating inside an elevator. Ultimately, mastering the FBD is a bridge for physics concept to accurate mathematical solutions. Moving on to our project objective. We have three main goals for this study. First, we want to study and understand how Newton's law of motion applies to two specific cases, a penalty kick and a transport truck. Second, we will use mathematical formulas and differential equation to calculate key variables. These include force, acceleration, and resistance and trajectory for both case studies. Third, we aim to analyze how mechanical force impact a low mass object like a football versus a high mass object like a transport truck based on our MAT272 principles. In short, this project connects mathematical theory directly with real-world physical motion.
Case study 1. The penalty kick. During football match, a player executes a penalty kick by applying a powerful horizontal force of 180 Newton to the right on a stationary 0.45 kg ball. At the exact millisecond of impact, a kinetic frictional force of 50 Newton acts to the left, opposing the ball's forward motion against the grass surface. While the upward normal force from the ground perfectly balances the ball's weight vertically. By isolating these interacting force vectors, we can apply Newton's law of motion to analyze the ball's immediate reaction. Discussion 1. Net force along the horizontal axis. To find the net force Fnet, we look at the horizontal forces acting on the ball, taking the direction to the right as positive and the left as negative. Kicking force as F plus 180 Newton to the right, frictional force Fk, negative 50 Newton to the left. We move to the calculation. Fnet equal to F minus Fk. Fnet equal to 180 Newton minus 50 Newton. Fnet equal to 165 Newton to the right. Discussion 1. 2. Acceleration of the ball using Newton's second law for the horizontal component. Fnet equal to ma. We can solve for this acceleration. A. By using the net force and the mass of the ball, n equal to 0.45 kg, Fnet equal to ma, 165 Newton equal to 0.45 kg multiplied by a equal to 165 Newton divided by 0.45 kg, a equal to 366.67 meters square. The ball accelerates towards the goal at a rate of 366.67 meters square and the exact moment of impact.
Next, we move to case study 2, the transport truck. During a highway haul, a large transport truck applies a forward driving force of 4,500 Newton to pull a heavy cargo trailer with a mass of 1,200 kg. At highway cruising speed, a kinetic frictional force of 900 Newton acts in the opposite direction against the trailer's tire, while the upward normal force from the road perfectly balances the trailer's weight vertically. By isolating this interacting horizontal and vertical vector acting on the trailer, we can apply Newton's law of motion to analyze the system of dynamics behavior. Discussion 2. First, net force along the horizontal axis. To find the net force, we look at the horizontal force acting on the trailer. taking the forward direction to the right as a positive and the backward direction to the left as negative. Pulling force, positive 4,500 Newton to the right. Frictional force, negative 900 Newton to the left. Force net equal to F minus Fk, which is 4,500 Newton minus 900 Newton. And the answer is 3,600 Newton forward. Second is acceleration of the trailer using Newton's second law for the horizontal component. F net equal to m multiplied with a. We can solve the acceleration by using the net force and the mass of the trailer. Mass equal to 1,200 kg. F net equal to m multiplied with a. 3,600 Newton equal to 1,200 kg multiplied with a. Next, a equal to 3,600 Newton divide 1,200 kg. And a equal to 3.0 ms negative 2. The trailer acceleration forward at a rate of 3.0 ms negative 2.
To conclude our presentation, mastering free body diagrams is the most critical step in solving any physics problems involving force. By isolating an object and simplifying it into a single point, an FPD allows us to clearly visualize every vector's force acting on a system. This includes gravity, normal force, applied force, and inflation, all without any environmental distraction. Ultimately, this visual map serves as the perfect bridge to Newton's second law. Whether an object is accelerating on a flat road, sliding down a tilted incline, or moving vertically inside an elevator, the core process is the same. Breaking force down into horizontal and vertical components transform a complex real-world situation into a straightforward algebraic equation that can be solved with precision.